All right, so let's continue our discussion for lesson 7.1. And we start with the working with percent problems. So the most common type of percent problem application, especially for this topic, is going to be on sales tax and discounts. So when we talk about sales tax is a certain portion of the cost that is added to the cost. This is added on top of the item cost. All right. So pretty much the sales tax amount is identified by multiplying the item's cost and the tax rate. So let's have this example here. So we have a purchase of bicycle for $894 and the sales tax rate, as you can see, is 7.5%. So how much tax is going to be paid for letter A? So the sales tax, as we have mentioned, will be the tax rate multiplied by the item cost. And so in this case, 7.5%, again, we do not work with percent. We need to change them in decimal form, especially for the calculation. So this is going to be equal to 0.075. 0.075, we multiply that by the cost of the bicycle, which is $894. And so that sales tax, plugging it into your calculators, you will get $67.05. So this amount, okay, so if we're going to be looking of how much are we going to pay in total for the bicycle. So the total cost, the sales tax is always added, okay, on top of the cost of the item. So 894 plus, okay, our sales tax, which is 6705. And so getting this sum, our cost now is up to 961.05. Okay, so the sales tax is added on top of the cost. Discount, on the other hand, same scenario. You have to multiply the rate and the original price. But this time, the discount is subtracted. This is deducted from the cost. Okay? That's why people love it when there are lots of discounts from mall. The cost of the items are cheaper, subtracted from the price. Okay? So, again, sales tax is added on top of the price, discount subtracted from the price. The process is the same, only the operation will be different. So for example, we have this computer, the cost is $1460 and it is on sale at 15% off. Okay, so if we are going to find the discount amount, so the discount is going to be the rate times the cost, or the price. So 15% is 0.15. Multiply it by 1460. And so getting onto your calculator, this price is going to be equal to $219. So the new cost, so now the total cost is going to be the price of the computer, 1460, minus our discount price, which is $219. So instead of paying $1460, you are now just going to be paying $1241 for this computer. All right. So definitely, as you can see, there will always be some changes on prices when it comes to sales tax and discounts. Now, another application of percent is if we would like to see how much was the increase or the decrease of certain values. And so for us to be able to find the percent increase or percent decrease, we simply need to, okay? So as you can see here, it's pretty much the same formula, this part and this part. The only thing that changed was the words increase and decrease. But basically, the numerator is the difference of values, okay? The original versus the new minus the new, divided by the original value, okay? And whether it's increase or decrease, all you need to do is find the difference of the two values. All right. Let's have this example here. So this graph is showing the world population projection from 2000, and the projection is for 2150. Okay, so this question is asking what is the percent increase of the world population if we're going to use the high projection data. The high projection data is giving us 30 billion as the population for 2150. Okay, so the percent increase, so let's get it here, percent increase is going to be equal to, okay, we find the difference of the two values, the original value and the new value. So in this case, our original value is 6 billion. The new value is 30. So we subtract those two, 30 minus 6, divided by the original value, which is 6. Okay? And so here, we will get 24 divided by 6, and this is going to be equal to 4. 4 is a whole number, and we need 4 being a decimal, okay? We need to change it in percent. And where's the decimal point of 4? 4 has a decimal point after it. So if we're changing it to percent, we need to move 2 decimal places to the right, filling up this spaces here. This is going to give us 400%. So the population using the high projection is going to increase by 400% in 2150 if, again, the high projection is used. All right? Similar question, this time, we're going to be using the low projection. So we are looking for the percent decrease. So for the percent decrease, same scenario. Like I said, find the difference of the two values. The original value is 6. And using the low projection, we are ending up with 4 billion for 2150. So again, just find the difference of the two. So that will be 6 minus 4 divided by the original value, which is 6. This is going to give us 2 over 6, which, if you change to decimal, will become 0.33333. Actually, that's going to be repeating. And if we change this to percent, this is going to give us, we have to move 2 decimal places to the right, which will end up giving us 33.3% decrease. Okay, decrease. So one thing I'd like to highlight, in the numerator, we do not care about the or. We just want to make sure that it's always the bigger value minus the lower value, so that our difference will be positive. And like I said, it's a percent increase, percent decrease. We just want to see the difference of the two values over it's compared to the original value. And that's it. Thank you very much.